Okay, so now they record it. Sorry, I don't know what's going on. Okay, again. When you're looking into the symbol, you're able to recognize they will be the FET, okay, N channel or P channel. That's a very, very basic. Today we get the first one, MOSFET, okay? And what they said, the MOSFET, that's the first one, can be operated in two mode, either depletion mode or enhancement mode. Okay, remember, the MOSFET will be working the same like the FET. Okay, however, they get two different mode, depletion mode or enhancement mode. Okay, sometimes called depletion enhancement MOSFET. Either positive or negative gate voltage can be applied. That means the voltage applied to the gate. Okay. For the depletion mode, when the negative gate to the source voltage applied, if you apply a negative, they will be depletion mode. That means they're working like they fed. Enhancement mode, when the positive gate to the source voltage is applied. Okay, generally operate in the depletion mode. So that means same thing. What I'm saying, they working like same effect. Now, enhancement mode. Enhancement MOSFET, that will be E MOSFET. You can see the symbol, they look like almost the same, but are not the same. Okay, you recognize this one here. Okay, they will be the same. Okay, however, on the other one, they broken right here. So that will be E MOSFET. Okay, and one N channel and one P channel. Okay, N channel error coming in, this coming out. Okay, N channel require positive gate to the source voltage. Okay, that means you apply positive to the gate here. P channel require negative gate to the voltage here. Equation transfer characteristic curve differ from that of the FET and the MOSFET. Okay, so basically E MOSFET, they working a little different from the JFET and the D MOSFET. Okay, you can see in here, this one you already see that. Okay, they will be for JFET and D MOSFET. Okay, and for either P channel or E channel. For a certain D MOSFET, they give an idea that 10 milliamp VGS of minus 8 volt. Is it an N channel or P channel? Okay, you already get a solution. The device has a negative VGS of, therefore it's an N channel MOSFET. Okay, this way we already learning from the fact. If you want to calculate the ID, same formula, exactly the fact ID that times 1 minus VGS over VGS of square. Okay, and if you want to calculate that, ID and calculate ID for VGS equal plus 3 volt using the formula. And that will be the plug here. You get 18.9 milliamp. Basically, I can tell you, you get a job interview for the technician, they not go into too much detail to calculation. Okay? The thing is the one, interview you, I believe they already forget everything. Only thing in general they can tell you. You say the symbol, you tell me what the name of that device. Okay? Otherwise, they don't want you to do calculation. And now they get another problem and you try to do, okay? Certainly MOSFET, IDF at 18 milliamp VGS of 10 volt. Is it N channel or P channel? Okay? They want ID with the VGS plus 4 volt and ID VGS equal minus 4 volt. They almost the same. On the other one, they already given you the solution here. If you answer the first one, is it N channel or P channel? Can you tell me?
P channel.
P channel.
What channel?
P channel.
Well,
channel.
how do we know?
Positive.
Exactly. VGS of positive. Okay, that's very good. Okay. And now, the MOSFET transfer. You can see the transfer here with the one we only know about D. MOSFET or JFET, they quite different. Okay. This one they call a VGS TH. Okay, not VGS off. Okay. That's for N channel or P channel. That's the difference. Okay. Now the equation for the parabolic transfer characteristic curve of the MOSFET differ from that of the JFET and the MOSFET because the curve stuck at the VGS rather than VGS off. Okay, on the horizontal axis and never intersect the vertical axis. The equation for the MOSFET transfer characteristic is, if you want to calculate the ID, you cannot using the formula for the JFET and the MOSFET. You have to using this formula. ID equal K times VGS minus VGS TH square. That's the difference. Okay? So if you get the formula, you're able to apply and calculate it. In this formula, the constant K, that's the K right here, depend on the particular MOSFET and can be determined from data sheet by taking the specified value of ID. That's what they call ID on. Okay? ID on, that means the value they given to you go with the MOSFET at the given value of VGS. And now they're giving you the example here. The data sheet for this MOSFET given ID on. You see that? That means they already given to you 500 milliamp minimum at VGS 10 volt. And VGS TH, they given you 1 volt. They want to know the drain current for VGS at 5 volts. You first thing you need to calculate the K. Okay. K, if you want to using this formula, you already now get the VGS, VGS, Now you will have to calculate the K. K will be equal ID on divide VGS minus VGS TS square. That means from this formula, you can calculate the K. However, ID must be ID on. So that's why you calculate it, you can get 6.17 milliamp per V square. Next, you're using the value of K to calculate the ID for VGS 5 volts. ID equal K times VGS minus VGS TH square. And that's why you can get 98.7 milliamp. It's not hard to do it, okay? Only thing is, before you want to apply the current, calculate the ID equal K times VGS minus VGS TH square. You need to calculate K first, okay? And a sample problem. The data sheet for E MOSFET given ID on. You see that? That goes with the MOSFET and VGS equal 8 volt. VGS equal 4 volt. Find ID when VGS equal 6 volt. Okay, same thing like the example. Only thing is you have to calculate K first. And after you get K, and that's why you can calculate the ID. Handling precaution. All on the MOSFET device are subject to damage from electrostatics, discharge ESD. Okay? Normally, when you get hired to working for the company, the first thing they training to you, that's training for handling. Okay? The device. That's exactly what we get here. Like before I even engineering, when I get hired, I have to go to the training for handling. Okay? Most device be shipped and stored in conductive form. All instrument and metal bands used in assembly or test should be connected to the earth ground. So that's why normally when you're working on it, you connect the wire connect to the earth ground. The assemblers or handlers which should be connected to the earth ground with the length of wire and a high value series resistor. Never remove and mod device from the circuit while power is off. That you must memorize that. Okay? Interview they can be asking you. Okay? You cannot remove the mod device while power still on. And the next one, they say do not apply signal while DC power is off. That's the thing you have to memorize. Okay? If you want to apply sideways, whatever, then the power DC must be on. Okay? Okay, example, determine the drain volt to short voltage in the circuit. Okay? In this circuitry here, the MOSFET data sheet given VGS off. Okay? Equal minus X and IDSS 12 milliamp. Okay, on this one here, okay, they say since VGS equals 0, okay, ID and IDSS the same in the JFET or in the DMOSFET. Okay, so that's why ID equal IDSS equal 12 milliamp. Therefore, VDS equal VDD. Okay, minus the voltage drop here. Okay, VDD minus IDSS times RD. The answer will be 10.6 volt. Okay, this one E MOSFET. Bias. Basically, you understand either bipolar transistor, JFET or MOSFET, they have to get the DC power to make it working. That's a bias, DC bias. They determine VGS and VDS for a MOSFET circuit. Assume this particular MOSFET has a minimum value of ID on and VGS equals 4 volts, VGS TS equals 2 volts. Okay, so basically, first thing you have to calculate the VGS right here. Okay, voltage divider, right? You can take the 24 volt times R2 divide R1 plus R2. You get 3.13 volt. This is don't have to do calculation. But in the field, they will be asking you. Okay, if you want to calculate the VGS right here, how can we do? Then you have to tell them we're using the voltage divider. Take the VDD times R2 divide R1 plus R2. But you don't have to do calculation. You know how to calculate it. To determine VDS, first find K. Okay, the thing is, this will be E MOSFET. You have to find K, and this is the formula to find K. Okay, and after you get K, then now you can say VDF equal VDD minus IDRD. Okay, so that's why you can get the answer. Okay, that's a summary for you. Okay, this for JFET we already done, and this is a formula. Okay, every formula in here, and that's the MOSFET. Okay, summary, and that's E MOSFET. Okay, E MOSFET. Okay, voltage divider, or they can using drain feedback bias. That means DC bias. Okay, and now this is just an example. They given you this circuitry. You're looking into here. You know that will be E MOSFET. Okay, they want to know VGF and VDF for E MOSFET circuit. So assume this particular MOSFET has a minimum value ID on at VGS on and VGS TS equal 4 volt. Okay, this one I guarantee you're able to do your calculation. First thing VGS, they say voltage divider. You get that? Then you have to calculate K. And then after you get K, you can calculate the ID. Then you calculate the VDF equal VD minus VF. And also another example. They want to know amount of the drain current in the circuit. So MOSFET has the VGS equal 3 volts. Okay, and in here, they measure telling here VGS, you already know right here, 8.5. Okay, they connect a meter. And if you get a VGS, first thing that will be E MOSFET. You have to calculate the K. Okay, and what else? You try to figure out. You get to it. Okay, so basically, finally, that's just a review. Okay, so the P channel JFET have a positive or negative VGS. So if you already go through the JFET, try to memorize it, go over and over and over in order to answer just basically telling the people you understand. So P channel, and you know you get a positive, right? And the number 2, and number 3, and number 4, number 5. Okay, just go through that. You can be see that somewhere in the final. The drain to the source voltage at the spin off point of a particular JFET is 7 volts. If the gate to source voltage is 0, what is VP? VGS of a certain N channel. JFET is increased negatively. Does the drain current increase or decrease? What value must VGS have to produce cut off in a P channel JFET with the VP equal minus 3 volts? Okay, so that will be done for basically for the MOSFET. Okay, now I try to see. Okay, now we're talking about field about JFET amplifier. Okay, so for that circuitry, normally we doing any calculation, then we have to know what the DC circuitry using to make the JFET working. You understand how many things. You can get the first one will be fixed bias. The second one cell bias. Okay. And the next one will be divider bias. So if you're looking into this circuitry, you can tell me what type of DC they make this JFET working. What type? You have to tell me. When you're looking into the circuitry, what type of the DC bias? You get a fixed bias, cell bias, divider bias.
Self-bias?
Divided by.
Come on, one. Who else? I know what I'm telling you.
By.
When you're in the field, They're not asking you asking you to do the calculation, but a general thing you have to understand. That's a basic. When you're looking into the circuitry, they're using the JFET to be the amplifier. Okay? But the thing is that JFET will be built from cell bias, switch bias, or voltage divider bias. Which one?
Self bias?
Perfect. Cell bias. Cell bias, that means at the gate here, they connect to the ground, no DC. If you get a DC voltage here, there will be a switch bias. Okay? That will be cell bias. And the cell bias, if you want to solving for the anything, you need a graphic, they go with that. However, normally they're not using the graphic. If they're not, then they given you the current ID. You see that? They given you the current ID 1.96 milliamp. Again, when you're working with a JFET or the MOSFET, the current ID here, and this is the current IF. ID and IF always will be the same. So you can get the IF here. That's easy for you to calculate the VF, right? VF equal ID or IF times IF. Okay? So in here for common short amplifier, that means when you see the circuitry, you must be memorized. Is it a common short, common drain, or common gate? Okay? Even you don't remember the formula, that doesn't matter. But at a minimum, we'll be asking you. Okay? And this a common short, the thing is signal applied to the gate output from the drain. Okay? And input output, I think they will be 180 degrees of phase. Okay, for common short amplified circuit, so they give an ID at VGS off. ID equal 1.96 milliamp. They want to calculate for VGSQ, VD, VF, GM0, GM, input impedance, output impedance, voltage gain, AV, and the VR. That's what we already done in the JFET. And this will be the answer. Okay? If you get the time, you try to working on that to see if you can get that answer or not. Okay, the next one. What input resistance is seen by signal source? IGSS 30 milliamp. Okay, SVGS equal 10 volt. Input resistance at the gate of the FET IE. That calculated by VGS divide IGSS, you get 333 mega ohm. Input resistance seen by a signal source. Okay, will be G in equal RG parallel with R in gate. And that you calculate 9.7 mega ohm. But the thing is, of what I'm telling you, you are just a technician. Okay, you don't have to do your calculation. Only thing is when you're working on the circuitry using the meter, using the oscilloscope, you can measure the voltage or signal as they asking for. When in the field, they just asking for you the basic understanding. The thing is when you get into the company get the way they're working, they will be training for you, but they cannot training for basic understanding about electronics. Another third example, okay? So you can see the MOSFET amplified showing here, okay? They want DC drain voltage VD, AC output voltage V out. If we in 500 millivolt IMS, and this is the solution, okay? You get the time, you can try to do, okay? And also this is amplified, they using the fixed cell bias. This is a cell bias. You see no voltage here. Okay. Another circuitry for E MOSFET. Okay. The common source amplifier using E MOSFET. Okay. Given the following ID on and VGS 4 volt. VGS TS here. They're given to GM, okay, equal 23 milliseconds. Simon, V in 25 millivolt IMS. They shown for VGS, ID, VDS, V out. And this is that we already get the solution. VGS calculate for VGS, you get, then you can get the ID. After that, VDS will be output impedance. Okay. And you get the out equal GM time, whatever. Okay. So that will be done for the FET. Okay. If you don't have a not in the meeting, then you can watch the video. Okay. And also on the next week on sample for the final. Okay. I will go through that with you, try to see how can we do. Okay. And I try to record that. But you're working on the sample. And the final will be mostly like the sample, just asking the student for basic understanding, not too much calculation into detail. Okay. So any question or anything?
So how much of the labs are gonna be on the exam? Or
How can you
like yeah, so because I know there's like more topics and I guess more information when we do the labs. I was just wondering how much that would map to the exam.
no? That will be very, very basic. If you understand bipolar transistor, diode, Zener diode, anything, the question will be basic. Left volt. You understand in left volt. If you go into too much detail in the left volt, take you 2 years to complete that. Left volt is very good for training. Okay. However, sometimes something basically for technician, they not required. So normally you're doing for the left volt, they can explain to you that are perfect, and they can asking you multiple choice A, B, C, D. Okay, that just helping you to understand, but that is not, requirement. The requirement is when they want you to build the circuit, and you know how to build, and they want to apply, measure, whatever, then you can get it done. That'd be good to me. The thing is, nowhere they can get equipment like this program. Okay? Even city college, same thing. They cannot. They just training like, more theory. We training more practical. The thing is, I'm engineering. I'm working for company for 27 years. I know whatever technician need to do the job. That's what we focus on that way to training for your guy. If I asking you, you can do it right away. That means you're okay. Okay. Basically, we get only 2 more weeks. Then we start with the new semester. I will be let you know who will be registered for TechQ on the spring. Even you not completely done for the level. Okay? Maybe you're still missing some circuit board not done. That's okay. The thing is when you go into TechQ, you're still working on that to finish it up. Right now, we don't care about much the time. Take one asking for 450 hours. Take two, same thing. And the hour now is out of my hand, not like before the COVID-19 on 2020. Now the time controlled by the city. If you go through the semester, you get 450 hours. But that not mean you say you get a 450 hours, you can complete take one. No. You get through take one, 2 requirements, 450 hours. No big deal to me. The big deal to me is just how much you done in the program. That asking major thing will be level and the final. Okay? If you get any question, then just bring it up. Like TechQ, they're not asking for how many students. The thing is, anyone want to get into this program, they must be take one first. After they done take one, then they can go to TechQ. No one can sign up for TechQ without take one. You understand? I run this program for over 35 years. And basically, we did better and better every time. Some students, they asking for CT. He want to get the certificate. And CT asking me. The thing is, the certificate have to be signed by myself. If I sign it and it's given to the CT to do it, they do it. The thing is, when they asking for the certificate, I have to looking into the history to see how many hours they get, how many left they done. Okay, or any test they done for like one. Then I can say okay. That's why they can do it. Otherwise, nobody can given the certificate for this program, even the dean or the manager at the Mid City. They just do what I want. I let them know. I say, okay, they do it. Okay, anything else? Okay, if it's not, then I will stop the program now. Okay? So, good night, everyone.
Good
Good
night.
night.
Thank you.
All right,
Good
thank you.
night.
Yeah, you're welcome. Okay? We'll see you Tuesday.
All right.
Okay? Bye.